In this example, we're given a conical cup through which water is draining. We're told that the volume of water decreases at a constant rate. And what we'd like to do is relate the change in the volume to a change in the height of water inside the cone. What we're given is that the volume of water, the derivative of that with respect to time, is some constant, and I'll indicate that this is minus k since the volume is decreasing. What we'd like to do is figure out at what rate the height of the water in the cone is changing. Now, what have we got going for us? Let's draw another picture in which we indicate a big triangle that sits inside the cone with radius r and height capital H. The level of water inside the cone is given by height little h and radius little r. We've got similar triangles where the large triangle is similar to the smaller triangle, and in that case we know that the ratio of little r to capital R is the same as the ratio of little h to capital H. The volume is given by 1/3 pi r squared h. That's the volume of a cone of height little h and radius little r, namely the volume of this blue region that's shown here. What we'd like to do is figure out dH by dt. However, we've got r mixed in here. Let's eliminate the radius using this similarity principle. In fact, let's use this to write r is equal to capital R over capital H times little h. And let's go ahead and plug this in for the radius right here. And when we do so, then the volume of the water can be expressed as 1/3 pi multiplied by the quantity capital R over capital H times little h all squared and another factor of h outside. We can restate this whole thing as 1/3 pi capital R squared over capital H squared multiplied by h little h cubed. Based on that, we can now compute the derivative rate of change on this side, and what we get is, using the chain rule, 1/3 pi r squared over h squared. These are all constants out front, multiplied by 3h squared, and we should not forget to add dH by dt based on the chain rule. As a final step, we solve for dH by dt by taking all of this to the other side and using the fact that dV by dt is given to us as minus k. And that's shown in the book.